Hello everyone, in this video I want to show you the undervolting for this Ryzen 7800X3D CPU on a B650 HDV M.2, but it's actually an H model. So here's 12 hours of core cycler. Let's look at the load power consumption during Y Cruncher. So we're seeing about 75 at the moment, 72 at the moment. So it hasn't even reached 75 watts so far. This is probably the most intensive benchmark you can run on most systems. 74.2. The results should be in the 145 ballpark. Admittedly, 145 was the result with high priority. Now I have hardware info on and the priority is set to normal so that I can look at the power consumption figures. So it should be higher. Okay, sorry, I was thinking about the result with the tier, the refresh interval at stock value. We are now with 32,727. What is that? Here's the settings from Zen Timings. Here's some Limpak runs. Now let's run PyPrime. Here's PyPrime 197. I was just double checking with, for example, this actually hardcore overclocking video on the same CPU and much lower settings, and it has much worse results than I have for Limpak, for example. And TM5 takes a lot more in his system. I can't show you mine, but it's 118 minutes for the whole Testament 5 run. So yeah, the result seems to be better than expected, and I think that's because of the very aggressive curve that I set, and I will show you that. Here's a couple of Y Cruncher VT3 runs. As you can see, they're fairly stable between 907, 906 and 9.1. And here's the settings in the BIOS. So VDDI voltage is 1.1. Yeah, it's weird, but that's the best results where we're at. And VDD 135 and VDDQ 1.3. Again, 1.3 seems to be the sweet spot for this. Yeah, it's weird to have all these nice round numbers, but that's it. But for example, the SoC is 1.11 for the best results. VDDP is 105. This one doesn't change. These two, I tried a couple of settings and tried to decouple them to see like whether 0.8 would work, for example, but 0.8 shows some regression in Limpak scores, which should never be the case when you're undervolting on such a power limited CPU. So 87 was giving me the best results. Admittedly, I didn't have time to run that like 3 times, 4 times, but just twice. Most settings were only validated twice because of lack of time. But for example, the VDDP, that was one of the most interesting one because it would still work at like 1, and 1 would give me like slightly lower Limpak scores, and that was consistent. Like 1.1 was giving me the lowest, and I tried a 103 and it would give me lower than 105 but better than 1. And yeah, 105 was the one which was sweet spot basically, the one would give me the best Limpak scores. And Limpak scores were very consistent between run to run, like in like 0.3 variation. So I would consider that to be good, and how to say that, yeah, a valid result to check. So here's my, I don't know whether this works. I didn't have time to check it, but just sure it's stable. This works, and this is also minimize this, like the lowest I can go, and this helped a little bit with Limpak score, so it was working. And now the most annoying part, which is of course the curve optimizer. So I was able to pinpoint by halving Halving means that I tried to set, for example, all the settings to 20 and everything was good. Then I set like everything to 37 and I had some regression. So I set the first half to 37 and I had no regression. And I think I pinpointed at the end that the error was between the core 4 and core 5. But it's super hard because errors for this curve optimizer setting are so hard to show. They're usually, in my experience with this setup, for example, I would get errors well, like at the beginning of a Y Cruncher run, on a VT3 run, or error as soon as I launch Y Cruncher, or as soon as I launch Limpak, like in the first 2 runs of Limpak. Core Cycler was just error at like around 40. Like to get Core Cycler to actually throw out an error, I would have to go in the 42, 43 range. But 42 to 43 would instantly crash Limpak, for example, always. So it was very hard. And also I was having performance regressions in Y Cruncher and Limpak. And this is the setting that gave me the best results. But you can sure work more on that, and I'm not 100% sure that's stable, sadly, but it's super hard to test this on Ryzen. I had this system for 1.5 weeks, so like 10 days of testing, and that's the best I could do. I'm sorry about that. Again, this motherboard is a B650M-H, but I cross-flash it with the HDV BIOS just to have curve per core curve available, because the stock H BIOS doesn't give me precision boost overdrive curve settings per core available. I only have some preset like this one and at the beginning, like this one. I can only set this. Yeah, the memory is not tuned, other than setting the refresh interval and setting the CL and then TR, CDR, DRP and TRS to like be stable at 6200, because this is a 6000 CL30 kit at 1.4 volt by default. Like this is the stock XMP. Oh no, it's 135. Sorry, that's a very good kit. CL30 at 135 is amazing actually. But yeah, didn't have time to really minimize everything here. But I have to deliver the system to the client, so that's it. And a quick check of after 7 minutes of idle on the desktop of our package power, and the lowest we got was 16 watts. That's not amazing, but that's what we get with Ryzen with the SoC architecture. And here we are playing Battlefield. Let's see how it goes during gameplay. I'm also using this phone to give the internet to the machine, so yes, around 180 FPS. 9070 XT is the GPU. I have no reference for this, I don't know how it should perform, but surely looks good. Arc Raiders shows a huge GPU limited. We are at like 6 milliseconds for the GPU and about 3.5, 2.7 to 3.5 for the CPU. So yeah, I mean it's a 3D CPU, so it's the best you can get, and it's quite well tuned, so that was expected. 160, 170, so everything is set to high, and ray tracing to medium, and FSR to balanced. Okay, so here's the settings. So equilibrator is balanced, and yeah, ray tracing is medium. If you go, yeah, everything is set to high. That's the high preset. Let's fight the Leaper. 170, 180 FPS. Very stable. Oh, I saw 150 at some point. Pretty sure I did. But I also saw 180, so that's good. Okay, so I saw 140 again during the fight with the Leaper. That's so epic. This game is so good. It's bad?
Mm-hmm.
Nice. So yeah, I saw 140 as the lowest, but we're mostly GPU limited. As you can see now in the menu, we're 200 FPS and more, so clearly GPU limited setting. So here's the machine finished. It's a M80X case, and we have a 120mm all-in-one cooler, 120mm on the back for the whole system, 9070 XT. Steadily, OCCT power still reaches 89 degrees, 89 watts. It's all very round, very interesting. And yeah, I guess there's no escaping the high thermal density of this CPU. But we'll see. I guess the real test is the gaming session, because the most likely scenario for a crash is usually single core boost at high temperature. So we have to see what happens in the summer with gaming. During gaming, we saw a peak of 72 watts, so lower than Y-Cruncher. But yeah, OCCT Power really knows how to do its job. Okay, we're now looking for an option to disable the integrated graphics, as there is no such option in the standard Asrock menu. So I hope to find it here. I guess here. Yes, here it is. So yeah, that is important, I guess. We'll see if that works. And yeah, that freed up a lot of watts for OCCT power. I never considered that problem, because usually I guess I used CPUs without integrated graphics, or I had motherboards that would allow me to easily disable the iGPU, and I would do that. So I really forgot to do that here, and apparently it makes a good difference, at least in this test. Now, normal situations, you wouldn't really run anything on the integrated graphics, so that wouldn't be a problem. But yeah, here we shaved off, I would say, almost 120 watts, because we were almost at 100 before. The GPU is pulling 400 watts and sitting comfortably at 53 degrees. So that's not a concern at all. The fans are blasting, as you can hear, but that's not going to be a problem if you use headphones. And since this is a very small case, I like it that way. We like to play on the safe side. So we hit the 85 watts, 85 degrees thermal limit, but that's not a problem in usual normal usage. It's not gonna come out unless you really run OCCT power. And I guess that is all for the video. Ciao.